Today we're going to be taking a look at more linear equations and how we end up classifying them in one of three categories. So it should be noted right from the get-go that a lot of what we are going to be doing is just expanded practice and expanded difficulty from the 2.1 to 2.3 material. If you need to go back and take a look at the 2.1 and 2.3 lecture video on those particular sections, then I'd recommend doing that right now, because a large chunk of this overall process is going to be using what we learned in 2.1 to 2.3. We are going to incorporate a lot more of the distributive property with a lot of these problems, but beyond that, there's not really a whole lot else that's going to change in the raw process with calculating and finding answers for these things. Now the difference is that we are going to now get into actually classifying equations when we are going through them. My recommendation to everyone is that we don't classify until after we solve the problem. I do not think there is any reliable way to just look at a problem or an equation that's been given to us and say, hey, I know exactly how many answers there are going to be, or if this thing's a conditional equation, an identity equation, or a contradiction equation. I don't think there's any way at the beginning to predict what that's going to be and determine that right off the bat. So my recommendation is before we try and figure out which one of these three classifications a problem is at the beginning, just follow the process that we did in 2.1 and let that reveal to you which of these three types of equations we have showing up. I think that's by far the most effective way to do this, and I am personally not aware of any trick that's going to help you get to one of these three classifications any faster. But let's dive into these classifications and see what they actually are. So we have our kind of drawn out book definition that we have here. A conditional equation is an equation that is true for one or more values of the variables and false for all others. This effectively means there's one solution. Maybe in a couple situations there's two solutions, but for the most part with what we will be seeing, there's one solution. So this is where we get down to x equals 5, n equals -3, y equals 0, something like that. You can think of the conditional equation as our kind of standard issue. We are used to seeing this problem in this answer form, and we really want to see more of those. We'll take a look at what these graphs look like, or these equations look like graphically here. This is also something where the equations will intersect at exactly one point. So they cross each other in some way, shape, and form at some point on the graph. We then have the identity or identity equations. This is a case where an equation is true for any value of the variable. This effectively means that there are infinite solutions. I can plug in any x value that I want, or any input value, really, that I want, and I'm always going to have the left side of the equation equaling the right side of the equation. If we were to look at this graphically, it means that these two equations are identical to one another. There's no difference in anything other than maybe the way they are originally written out, which is probably the most common way that we see identities show up in these problems. They look completely different at the beginning, but it turns out partway through the process, they're the exact same thing and they are identical. Quick little note with this, which I think is kind of fun, but it helps keep these things in line. And identity is identical and it has infinite solutions. We've got all three I's here remain together. So identity, infinite solutions, and identical graphs. Something silly and a student of mine a while back had come up with, and credit to them for coming up with it, but just noting that as something you could use if you're trying to remember which thing is which in these three types of classifications. And our last one, this is probably the weirdest one that shows up, but if I have a contradiction showing up here, an equation that is false for all values of the variable, meaning there is no solution. Should be noted, do not write in 0 solutions. The reason we don't do that is because in our conditional equation, if I have x equals 0 or n equals 0, the number 0 can absolutely be a solution. So to say there is 0 solution can be misinterpreted by some instructors and by some online programs or software that you're using to say, hey, your answer is the number 0. We're not stating that. We're stating there are absolutely no solutions. This can sometimes also be written as DNE, does not exist, but that will vary based on the program you're working with or the instructor that you're working with. But make it clear, no solutions or does not exist, not 0 solutions. And what this looks like graphically for our contradiction is that we have two lines that will never intersect each other, meaning that they are always parallel and never actually cross. And again, we'll take a look at some examples of these here shortly and what the difference between them on a graphical level looks like. And again, with this, I recommend absolutely never attempting to classify any equation we're given until after we've solved the equation and determine the number of solutions we do or don't have. Meaning, apply this 2.1, 2.3 process, and then classify at the very, 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 very end. We will go through and take a look at each of these 3 classifications graphically. Then we're going to jump into and take a look at these 4 example problems and determine and classify if each of them is conditional, an identity, or a contradiction, and then state the solutions that go along with those. So I'd recommend, if necessary, pause the video here, write these 4 problems down because we're going to go through them algebraically after we take a look at what each of these 3 classifications looks like graphically. Looking at these 3 classifications graphically, we are going to use the website desmos.com to view 3 examples of each of our 3 different classifications that we have. I would highly recommend that you bookmark or try the Desmos website for yourself. I think it's very, very handy, very easy and user-friendly to use to set up and graph equations and things like that. So we have our starting equation up here. We have 3 different examples showing up here. You can probably guess what these are going to be going to, but let's assume that we didn't know what the outcome was going to be, and we're trying to figure, okay, is this pair of equations going to be a conditional, identity, or contradiction statement? So let's compare our original thing that we have here, 3x minus 4, and compare it to y equals negative 6x plus 5. What you would generally see in an equation form is this 3x plus 4 equals negative 6x plus 5. We wouldn't see the y in there at all. It'll just be the x part equaling this x part here. So looking at it at face value, I don't think it's obvious looking at these things. Maybe it's a contradiction, maybe it's an identity, maybe it's a conditional thing, we don't know. But if we look at it graphically, hey, looks like we've got this green graph showing up here. These 2 things cross each other or intersect at exactly 1 point, and that point is 1, negative 1. So fantastic. Of our conditional, identity, or contradiction statements, this pairing of equations would be a conditional statement. Under the condition that my input value is 1, in this case my x is 1, then these 2 graphs are going to be, these equations are going to be equal to one another because they both have a y value of negative 1 right here. And we can see that again, they are not the same here, they're not the same here, or not at these spots, but under the condition that I have this one particular input value, then these 2 graphs are going to be the exact same. So our conditional statements have one single solution, one single crossing here. Now if we look at our next example here, we have 3x minus 4 equals 3x plus 1. These 2 things would be, we did see an equation set up like that. So looking at these, what's your thought on what sort of a classification are we going to use? And again, I don't think it's necessarily obvious at the very beginning, so let's take a look at it visually. And we notice that we have 2 lines that appear to be parallel to one another. Looks like they are never going to cross, and they continue on with this pattern forever. So between a conditional, identity or contradiction statement, or classification, I should say, this thing is going to be a contradiction. There is absolutely no place where these two graphs are going to cross one another. Therefore, I have no solution showing up there. And our last one that we have, again, we'd see 3x minus 4 equals 3 times the quantity x minus 5 over 3 plus 1. This is just an example. We don't actually need to go through and solve it for now, but just something weird that we're being given, because we will see weirder stuff showing up in these problems moving forward. And again, I don't think it's obvious which of the three classifications this thing is if you were to just look at this and this together. So to look at it graphically then, what do we end up having? And we see that this new graph here it lies right on top of our other one. Hoping the color is coming through fine. We're seeing that our original thing is in black, and our new equation here is showing up in red, and it lies right on top of one another, which means that these two things are identical. And if something is identical, then that means it's an identity, and an identity has infinite solutions. And we can look at this and see that, yeah, that kind of makes sense. Where does this red line and where does the black line cross one another? Well, they cross everywhere, which tells me they have infinite solutions. It doesn't matter what x value I choose, both of these graphs are going to have the exact same y values showing up there. So graphically, that's what our three different representations and classifications looks like. Just made up these examples here for going through them. I'm trying to have them all on display for if you wanted to see and take a look at each of those all at once. This is generally what we see graphically showing up with these types of problems. So let's go ahead and jump over and take a look at solving some problems algebraically instead of having to go through and graph them. Looking at our first example that we have here, we've been given 2 times the quantity x minus 7 plus x, and that all equals 3x minus 14. So like we did with our 2.1 through 2.3 material, we're going to lean into that process and let that process reveal the answer or answers, and therefore also the classification to us for this problem. So simplify the left side down first. I don't want this thing to be big and complex. I want to condense everything down where I can. I start that by distributing this 2 through to everything inside the parentheses, and I get 2x minus 14 plus x. Bringing down the equal sign. Combining like terms where I can combine the x's together, and I'm going to get 3x minus 14 on this left side. I can't combine anything else. One's a variable, one's a constant, so I'm done there in terms of how much I can simplify. On the right side, I have 3x minus 14. I can't combine any like terms. I don't have any other operations going on, so I'm just going to bring this 3x minus 14 down exactly as it is. Now from here, I'm going to put a little star by this one. If you get to this point and you notice, hey, these two sides of the equation are identical to one another, that can be your cue to stop and say, hey, I have an identity showing up here. I'm going to have infinite solutions. If you're someone who, looking at this, and you're thinking, I have not seen that, it's not clear and obvious to me, that's fine. You can continue on with the process from 2.1 and 2.3 and just, again, let that reveal to you what's going on. So I have variables on both sides. I want to get rid of this 3x on the right side here. And that's perfectly fine. That's your call. On the left side, I get negative 14 equals negative 14. Right here is again another spot where we're noticing, hey, these two sides of the equation are identical to one another. They're the exact same thing, which means I have an identity and I have infinite solutions. But again, though, if you're someone who's in the boat of, it's still not clicking for me, that's not obvious, that's fine. Continue leaning on the 2.1 and 2.3 process. I want to get rid of all constants on one side of the equal sign. So I'm just going to add 14 to both sides. And then I'm getting down to 0 equals 0. And again, we've kind of reached bedrock with this problem. We can't do anything else when we have 0 equaling 0. This is, again, an instance where we have both sides of this equation equaling each other. Both sides are identical to one another. So that tells me that I'm going to have infinite solutions as my final answer. So when you see problems like this, and as you're going through them and you're saying, especially with identities, at any point in time, is every single thing on the left side, all the numbers, all of the signs, all of the variables, the exact same as the other side? They are identical to one another. Then we can just stop here and go right to our answer of saying, hey, I have infinite solutions and I'm done. Our second example that we have here is 4 times the quantity x plus 2 is equal to negative 2 times the quantity 2x minus 1. Again, we're going to follow our 2.1 to 2.3 process and just solve this thing out and classify at the end. So simplifying the left side first, the 4 is going to distribute through to everything inside the parentheses. That's going to give me 4x plus 8. I can't combine anything else together. One's a variable, one's a constant. They have to stay separated. That's fine. We got as simplified as it can be. On the opposite side, I have negative 2 times 2x minus 1. This negative 2, the 2 and the negative sign are going to distribute through to everything inside the parentheses. You might notice that I'm doing this distribution over the top, this one down below. That's just to show that there's two ways you can write this out. Either one would work. So negative 2 times 2x, that's going to give me negative 4x. Negative 2 times negative 1, negative times a negative makes a positive. 2 times 1 gives me 2 here. And great, the right side is as simplified as it can be as well. Both sides are fully simplified, and I can now just continue on and solve this problem for our specified variable. So I have negative 4x on one side, and I have positive 4x on one side. I need to get rid of one of them. The hint from our previous video said that I'm going to get rid of the lower valued variable term, in this case the minus 4x. It has a lower coefficient, so we want to get rid of that one. So we add 4x to both sides, and our result is that we get 8x plus 8 on the left side equals 2 on the right side. And now again, I want to get my variable term all by itself, so I want to get rid of this plus 8, so I'm subtracting 8 from both sides. And I'm left with 8x is equal to negative 6. And again, still trying to get x by itself. This 8 is attached to the x through multiplication. This is 8 times x. I undo multiplication with division, so I divide both sides by 8. I'm getting x is equal to negative 6 over 8. Make a little arrow here. Finish this thing right off to the side. I can never have a non-fully reduced fraction answer in these problems, so I have to reduce this thing down. This negative 6 over 8 is going to become negative 3 over 4. And now I'm at a point where I have one single answer that's showing up, kind of our standard issue x equals a number answer. So based on that and based on our 3 criteria, these two things are not identical. I don't get a really weird thing showing up with contradiction equations. I have a conditional equation. And under the condition that x equals negative 3/4, these two sides of the equation are going to be equal to one another. All right, taking a look at our third example here, things are going to get a little messy on the left side and a little messy on the right side. But above all else, we are just trying to simplify each side before we start adding, subtracting, multiplying, dividing back and forth in this equation. So we'll do this in small controlled steps, as small as we can. Just do one thing at a time as you need to. So I have inside this set of brackets, I have a set of parentheses, and the 8 is multiplying to those. So I'm going to have this 8 distribute through to everything inside those parentheses. I'm not changing anything else, so everything else around it's going to stay the exact same. I'm then combining like terms where I can inside of this set of parentheses. I'm going to get 3, I'm going to have 32h minus, I believe it's going to be 33. Then off to the side here, I'm using a calculator off screen just to make sure I'm getting these numbers correct. We should be getting, when this 3 distributes through to everything inside, we should be getting 96h minus 99 on the left side. So big numbers, sure, but it's still nicer to look at than what we originally had up here because this thing was kind of a mess at the beginning. So let's apply this same thinking. We want to simplify the right side down. So this 2 is going to distribute through to everything inside the set of parentheses. It's going to give me 10 minus 24h minus 19. Make that a little bit better h. There we go. Combining like terms where I can combine the constants together. So I get negative 24h minus 9. I can't combine these any further, so I'm just going to bring this down exactly as it was here. So I now have 96h minus 99 equals negative 24h minus 9. Okay, fantastic. Let's go through and let's simplify this thing further. Or not simplify further, but let's start actually solving for our variable. So between 96h and negative 24h, I'm going to get rid of this minus 24 here because that's the lower number. So I'm going to add 24 to both sides. I'm getting 120h minus 99 equals negative 9. I want to get rid of this constant term on this left side, so I'm going to add 99 to both sides of this equation. Try and zoom this out and scroll us down here a little bit, give us some space. And I get 120h is equal to 90. I'm dividing both sides by 120. And from here, because I don't want to make this too small, I'm just going to move us off to the side. We're going to get h is equal to 90 over 120. I always have to reduce fractions down as best I can. Both of them have zeros at the very end, which means a single zero can cancel out. I effectively have 9 over 12. Both of these can be reduced by 3, and that's going to give me 3 over 4. So when I'm getting h is equal to 3 over 4, I'm getting a single answer, one single value will make the statement true, and that tells me, just like we did in number 2, that I have a conditional equation here. Okay, final example here. And yep, it's a complete mess of a bunch of stuff going on. Again, really wanted to highlight, lean on the 2.1 to 2.3 material, the process that we have for that. Let's fully simplify the left side, fully simplify the right side before we actually go in and find our answer. So I'm going to distribute this 3 on the left side through to everything in the parentheses, and I'm also going to distribute this 7 through to everything inside of that set of parentheses. Should be getting 18y minus 27 plus 7y plus 28. Let's make that 8 a little bit better. There we go. Now combine like terms where I can on the left side. I can combine the y terms together, the variable terms. That's going to give me 25y. Then I have negative 27 plus 28. Those combined is going to give me a plus 1 on the left side. So this is as simplified as it can be. Let's go ahead and take a look at the right side and simplify that down. So this 5 in front is going to distribute to everything in that set of parentheses. The negative 5 here is going to distribute to everything inside of this set of parentheses. I should be getting 30y plus 40 minus 5y minus 5. Be careful of that negative going through. It has to change all of the signs inside here. It's a small little thing that tends to get people as they're going through these problems. Then otherwise I'm just combining like terms, combining my y's together for 25y, and combining my constants together to get 35y. Fantastic. I'm now going through, and I'm just, since I have both sides is fully simplified, I'm going to get rid of the variables on one side of this equation. So I'm going to get rid of this 25y over here. I'm going to subtract 25y minus 25y. And what's my leftover stuff here on the left side? Well, these two things cancel out. 25y minus 25y, that's effectively 0y. And 0 times anything is just 0. So this whole set of stuff over here goes away. It's gone entirely. What about right here? Again, 25y minus 25y would give me 0y, so all of that cancels out. The only thing left over on this left side is the number 1. The only thing left over on this right side is 35. And here we have a completely false statement. 1 is not equal to 35. This is just weird. It makes no sense. What the heck do we do with this? Well, this is an example of our last classification that we had showing up. This is where we would have a contradiction. So as you're going through these, when you get really, really weird things show up, such as all of the variables canceling out with one another, and the result of that is two numbers equaling each other that aren't the exact same number. One's positive, one's negative, they're both positive but different, they're both negative but different, one is 0, one is something else, doesn't matter. If these two numbers are not perfectly identical to one another, the only outcome we can have then is a contradiction. Bringing everything together at the very end as a quick recap, a lot of what we're doing to find our answers and classify these things is dependent on the 2.1 to 2.3 material, the process specifically that we learned from that. We have 3 classifications for these equations: the conditional equation, where we have one solution, the identity, where we have infinite solutions, and we have the contradiction, where we have absolutely no solutions in any way, shape, and form. Again, my recommendation with pretty much all of these is that you do not classify these equations until after you have solved all of them and gone through the entire 2.1 to 2.3 process. I hope it was apparent through the graphical representations and each of these algebraic ones that it isn't obvious from the beginning which classification is going to be used for each particular equation. So really lean into letting the process reveal the classification to you rather than you trying to force one of the classifications just because you think that might be the case or you want that to be the case. We do also have some extra problems here that you can go through and try for yourself. Try identifying each of the following as a conditional equation, an identity, or a contradiction, and then state the solution. H equals a number, M equals a number, infinite solutions, no solutions, DNE solutions, does not exist, or a solution does not exist, anything like that. If you did give these a try, we'll get to the answers right down here. And hopefully you got something very close to these or the correct answers. If you didn't, that's fine. Take a moment to go back and review those and see maybe you had a negative sign show up incorrectly, or maybe you did all of the math correctly but we misclassified, if that's something that showed up. I don't think there's anything wrong with referencing the notes to say here's what the definition of a conditional statement was, an identity was, or a contradiction was. Reference those as much as you need to.